Hello and welcome. Today we're going to talk about LLM app deployment. I got a lot of questions from you, especially on my last video on local multimodal AI chat, along the lines of why didn't you also show us how to deploy it? And I think there are some misconceptions and I want to clear those things up. Things we need to know, what to consider when thinking about deployment, which frameworks you could use, and also explain the basics like load balancing, scaling, logging, which metrics to log, and in the end I'm also going to do a live deployment to show you how it's done. But first, let's talk about deployment scenarios. Because in that regard, deployment isn't just deployment. You have different use cases. Obviously personal use, like I have a video on 50 PDF books indexed in 5 minutes. This would be a hobby project on our own data. The deployment would be easy with small costs. On the other side, going to small businesses is going to be a little bit more complicated. There are such things like customer support chatbots, content generation, or generally chatbots on the data of a business, and they will have a little bit more cost associated with everything. Then the hardware requirements are a little bit higher, the scalability comes into play, and there are other focus areas. Instead of having an easy deployment, now you should think more about reliability, scalability, and cost effectiveness. And then in the last scenario, enterprise level, hundreds to thousands of users and queries per second even, so the costs are going to be a lot higher. You need a high-end infrastructure, and the focus area will be even more on scalability, robustness, security, and integration with existing enterprise systems, and comprehensive monitoring and maintenance. If you ask me how to deploy this, well, what's your use case? Do you want to deploy it for yourself, or do you want to sell it as a software as a service? And therefore you have to think about your use case at first. Let's talk about another very important topic, which I think many people don't think to the end. Local models versus paid services. Of course, with local models you have a high cost upfront because you have to run these on your hardware, and in the best case on the GPU even, which is not cheap. And with paid services like OpenAI, you pay per token, which in the end might be way cheaper. Of course, it depends on your customization needs. If you want to use uncensored models and do whatever with them, yeah, then you might need to go to the local route. But if you have some basic use cases like, let's say, customer support for a small business, then the paid service will be really good. And your local models require powerful hardware, CPUs, but in the best case even GPUs. And in the paid services, the whole infrastructure and processing is completely handled by the provider. So I want to make an example. Let's just quickly hop over to VS Code. Here I want to make a small comparison between loading the chat model on the CPU and on the GPU. I added a function in the chat chain class to monitor the time for how long it takes to execute the run function. So we see on the CPU, you're already waiting and waiting. Yeah, 15 seconds. And now we run it on the GPU. And you will see it's much faster, 1.5 seconds. Now, if you're having a lot of customers, you can't let them all wait 15 seconds. And in the GPU case, you even have parallel processing. So let's say you have 50 customers, you can process, depending on your hardware, you need more GPU memory, of course then, but you could process then all 50 requests in parallel and have really fast answers for all your customers. If you're simply chatting with a model and this would be a personal hobby project, okay, yeah, you can run it on the CPU. There's not necessarily a pressing need that is absolutely fast. You can use the CPU, but if you're working with customers, you might really need to work with GPUs, and this might cost a lot. I want to show you. So the GPU pricing, we have one GPU, 16 gigabyte, will be $0.35 per GPU per hour, and which makes monthly almost $200. And also here run pod will be also 32 cents per hour, which will be on monthly basis also $150. So that's the thing you have to think about, because you can't just simply deploy a local model on CPU, have 100 customers and everyone waits a minute on the response. response. No, you have to work with the GPU, and then you're going to have to pay $200 a month for that. So and therefore there's this misconception of people being annoyed to use OpenAI, but yeah, they have the whole infrastructure where you get your answer in a second and everything is built for you, everything is done. You don't have to think about this, and for that I'd say you pay a pretty cheap price when using OpenAI. And also another thing, again, here this is just a simple model. If you're working with PDF chats, for example, on my PC here, running the document chat on CPU might take 5 minutes for one answer. That's not a suitable solution. You can't work with that. Even though for a hobby project, if I would deploy that, I wouldn't want to wait 5 minutes for my answer, and I wouldn't pay for a GPU obviously for my hobby deployment. Therefore I would go the route of using OpenAI even for my hobby projects or for my personal deployments, since in the end it would be much cheaper and faster and easier. Okay, I hope I made this point clear here. So let's go back to the presentation. So the important point of scalability with your local model, it's limited by hardware. So again, you need to invest a lot of money, for example, to get another GPU to scale it up if you have a lot more customers. And with paid services, everything is handled with their infrastructure, and you would just have to pay for those additional tokens. The ease of use with the paid services, user-friendly, easy integratability, and for the local models, well, you need a lot of technical knowledge for the setup, for the maintenance, and also for making customizations so that everything is going to be as cost efficient as possible, as fast as possible. So many things to consider here. And the data privacy, of course, this is the best selling points for local models. You have complete control over your data. So if you're going to deploy an AI girlfriend with some naughty chats, well, there you have your high degree of customization and your complete control over your data. You might not want to let OpenAI see those chats, and also you might not even be able to build something like that with OpenAI or another paid service because of their censoring. So these are cases where you would want to go the local route. Also, the even bigger case is going to be the enterprise solutions. The enterprises, they often want to have the control over their data, but they have the financial means, of course, to support the infrastructure necessary to work with the local models. Okay, before I'm going to make a live deployment, I want to quickly show you the model serving framework. So I'd say in most cases we're going to use FastAPI for personal use cases, and for small business use cases, FastAPI will be your go-to solution. You can easily create and use and deploy API endpoints. It will automatically generate an API documentation for you, and it has asynchronous support, which is necessary to asynchronously send requests to the endpoints and to the model, and then send the answers back to the user. If it would be synchronous, then we would only make one request and then wait for the response. If the response is there, only then the next request could be made. But with asynchronous requests, multiple users can make requests, and in the backend, the handling of the requests is happening, and then the answer is going to be sent in that order. So for more complicated solutions, we have BentoML, RayServe, and Amazon SageMaker. The use cases are going to be end-to-end solutions. So if you're going to be training a model, or let's say fine-tuning a large language model, and manage the whole life cycle of the machine learning model or the large language model. So FastAPI is not a direct model serving framework. It's for creating Python-based web servers, API endpoints, and those three solutions here, they are the specialized machine learning serving solutions. In most cases, FastAPI is going to be your go-to solution. Easy to learn, fast, and I'm also going to use it later on in the live deployment. But first we want to talk about the important considerations when deploying LLMs or when creating an LLM app. Of course, I can't go in complete depth and explain everything in absolute length, but we will have a brief talk about it, and you will understand the basic notions and can go deeper when considering a deployment for yourself. So what we have here is scaling, load balancing, logging, monitoring, security and backups, performance and optimization. For the scaling part, I want to show you a picture. Let's quickly hop over to the browser. Here on this website, I found a really nice picture. You have vertical scaling, which basically means to increase the resources on the system you're using right now. So this could mean, in the case of LLM, to attach another GPU, and with another GPU, you can increase the batch size. So the batch size again just means to let the AI create an answer for multiple inputs. So let's say with the the GPU you had in the beginning, you had a batch size of 16, so you could handle 16 inputs in parallel, and now you have double the user, and therefore you vertically scale and attach another GPU, and with that you can handle now 32 requests. And horizontal scaling means instead of having one application, you would now scale up to 3 applications, and in this case all, for example, with the same 8 vCPUs and 33GB RAM, or one GPU here, one GPU here, and one GPU here, instead of having larger GPU or a second GPU on the same application or the same machine. You have 3 different instances of your application. The advantage of vertical scaling, if you already have the hardware, then of course it would be more cost efficient to use that and upgrade it and vertically scale, but you have a single point of failure. And with horizontal scaling, you have more resilience, more availability because you have more machines, more fault tolerance. With vertical scaling, you might have to shut down the server to increase the hardware, and with horizontal scaling, you can just add another instance, another machine, and don't have any downtime for your first instance. Depends on use case, what exactly you need and how the cost structure would be. So the next important thing is load balancing, especially if you're working with horizontal scaling, then load balancing is a necessity. Here another website which simply explains it. So you have clients requesting to your server, then goes to your load balancer, and the load balancer is just going to distribute the load, the requests to your different servers, to your different machines. So there are different methods for that, which are round robin, IP hash, least connections, and round robin just would be to send the request to one server, then to the next, then to the next, then again to the first, to the second, to the third, and just in that order. Or IP hash distributes the requests based on the IP address. Least connections tries to distribute the traffic to the instance which has the least traffic on it right now, so to balance this traffic out. You get the idea. Load balancer just balances all the requests among your deployed instances. So another very important point is logging and monitoring. You want to log the performance, and for that you have to define some metrics you want to log for and monitor. For example, in regards of your LLMs, queries per second, latency, tokens per second, the cost you have associated with it. Let's say you're working with OpenAI, then of course the amount of tokens you're sending, the cost you have with that, and we're also going to be tracking that in the live deployment. We're going to make after I finished explaining this page here. And for that you can use something like the ELK stack, Elasticsearch, Logstash, and Keyboarder. You have OpenTelemetry or Prometheus and Grafana, which are the open source solutions. There are also some other solutions from Y Labs, for example. They are pretty focused on AI models and LLMs. They will have different metrics from different categories: security, performance, and can monitor everything you need, have easy integrations. Another solution would be, for example, the port key. Also another possibility, the OpenTelemetry, which I already mentioned, which is completely open source, and with Prometheus and Grafana, which are also open source, and you can integrate everything you need. Regarding security, you can use the Open Authorization 2 standard, which is the I'd say state-of-the-art standard, which is used the JWT token, and again depends on your use case. With the Open Authorization 2 Bureau token, for example, you can have multiple users and give them specific permission for their API key. So this is very useful if you have restricted access to different endpoints. For personal use, you can use simple API key. You also always want to think about backupping your solutions. And for performance and optimization, you want to think about caching. Yeah, and for that you can use Redis, Memcached, FastAPI caching. Specifically in the case of LLM, you might cache the responses for which you get a lot of requests for. So just a simple example, let's say users would send the question, "Who are you?" to the LLM. And then you would have the response cached already and would need to send this query to OpenAI or to your local hardware. And you would have saved some money with that, with the decreased latency, because the answer is already there. So I hope this was a helpful overview for you. Of course, if you're going to deploy something and work with small businesses or even enterprise solutions, you have to dig deeper in those points, but I think this is a good starting point now. Now let's hop over to the live deployment. For the deployment, you want to head over to my GitHub repository LangChain FASS vector index. This is my code from the video index 50 PDF books in 5 minutes. Basically, it creates a vector index for your PDF files, and then with LangChain creates a document chatbot, which is then deployed for a Telegram chat. And then you can chat with your PDF files via Telegram. So we want to clone the repository, git clone, and then cd into it and open VS Code. So in VS Code, the first thing I want to do is change the branch to the ChromaDB branch. The main branch works with FISS index store, but I want to work with the Chroma database now because I like the background mechanics of the vector store a little bit more, how the adding of documents works, for example. So to give a really short overview, you have the add documents file here where you enter LangChain document. They're going to be embedded with the embedding function and added to the database. So the add documents function in database works in a manner that if the database isn't existent yet, it will create it first. So that's perfect for the deployment because we don't have to separately create it then, and just with the first adding of a document, create a database. So our document chat is working with LangChain retrieval Q&A and with the OpenAI chat. And here we have our Telegram bot, which is running, and if you send a message in Telegram, it gets to the handle message function to generate answer, which will call the retrieval chat, which we just saw, and get documents from the database based on your question, and then sends it to OpenAI and answers. So in theory, we could deploy it right as it is, but we want to add a FastAPI endpoint to be able to also add more documents. And I want to log some metrics, specifically the token usage and the cost with the OpenAI model, and also create a FastAPI endpoint to retrieve the metrics, so I can always get an overview how much cost we already accumulated. Okay, let's first start with the logging function, and for that I want to create an SQL database. So let's make a new file, SQL operations.py. I want to import SQLite 3, and from utils load config. Config file will be load config, import load config of course, and in the config file let us add SQLite database path will be, let's just call it SQLite database, and telemetry.database. Again, let's hop over to the SQL operation. We want to function to initialize the database. It's called initialize database. Then we are going to need a SQL connection, so a connection to the database, which will open up our database from database path. Then we need a cursor from the database. Now we need to execute this SQL command, which will create a table if it's not existent, which will be called telemetry with a primary key, which is an integer. We need a timestamp for everything that gets inputted in the database, and you want to track total tokens, prompt tokens, completion token, and total cost, which is going to be a floating number and therefore real. And at last, we need to commit the changes and close it. Next, I want a function called insert telemetry. It will get as input the total tokens, prompt tokens, completion tokens, and total cost. Then again, we will create the SQLite connection, get the cursor, and then we will execute the SQL command to insert into the telemetry database our total tokens, prompt tokens, completion tokens, and total cost. The timestamp is automatically created, and at last, commit our changes and close the database again. So, and now if name equals main, I want to call initialize database. When we have deployed our code, we're going to once call the SQL operations file and initialize the database, and after that we can interact with it. So now we hop over to the document chat again. From SQL operations import insert telemetry, and when calling our model we want to also from LangChain community.callbacks.manager import get OpenAI callback. And then we want to call with get OpenAI callback as cb. We're going to call this function and insert telemetry from callback. We get our total tokens, prom tokens, completion tokens, and total cost. And then we have it in the database tracked. The next thing we need to do is to create our FastAPI endpoint. So for that, I want to make a Python file FastAPI app.py. We're going to need a lot of imports. You're going to see how we will use them. Let's call load.env at first, then app equals FastAPI app. So we obviously want to secure our endpoints with an API key. So at first we want a function called getAPI and it will get as input the API key, which will be sent with the request. And then we're going to check if it does not equal the API key we have in our environment. Then we are going to send back an HTTP exception that it's an invalid API key. And if it is a valid API key, we're just going to return the API key. Okay, now I want to create an endpoint, get metrics. So it's a get endpoint. As input, it gets the API key, which depends on the get API key function. So it will check if the API key is valid. Next, again, we are going to connect to our database. And we are going to do it from the config again, SQLite database path, and from utils import load config and config will be load config. So there we have it. And we want to set the connection row factory attribute to SQLite free row, because usually when you return something from the SQL database, it will be in tuples, but I want it to be in as a row object, so I can simply get out the metrics which I need. And for that, we're going to take datetime now minus time delta from 30 days and turn it into a string. Next, we will execute the SQL command. So select everything from telemetry database where timestamp is greater than our 30 days ago string. Fetch all elements, then we have the rows. Then we want to extract each row and turn it into a dictionary. So each row into one dictionary within the list. So here we're going to have our matrix will be in the list, and every dictionary will have our prom tokens, total cost, and finally close the connection again, return our matrix. And with that, we have the matrix part covered. The next thing we need will be the endpoint to add documents. Okay, for the document uploading, I'm going to add a few functions in the utils.py file. We are getting the documents as bytes and we need to convert them into LangChain document objects. So here I'm going to add a few functions now. So I just added the functions get PDF text, which gets as input a list of the PDF bytes, and it returns a list of texts. So every object in the list will be the whole PDF file, and for that we are going to call the extract text from PDF on every PDF bytes in the list, and this basically gets all the pages and extracts the complete text from the whole PDF file. And then we have get documents chunks, which its input gets then the text list, which basically is the output of this function then. And for each text we're going to chunk it up and append it to the documents, and then we return a list with LangChain documents, each with the length of a maximum chunk size of 2000 characters, which are approximately 500 tokens. Now I'm going to head over to the add documents.py file, and here I'm going to import from utils get PDF texts and get document chunks, or from utils import. Now I'm going to create a new function, add documents from PDF bytes, and texts are going to be get PDF text, documents are then going to be get document chunks from the texts, and we just call the add documents function on all the documents we just created. And with that we have a functionality to add documents from bytes. Now we need to head over to the FastAPI app again and create another endpoint to receive the PDF bytes and call the add function. So now from add documents I'm going to import add documents from PDF bytes. Now we create the post endpoint called upload, and it gets a list of files and also again is dependent on our get API key function. Next we create a PDF bytes list. For that we will iterate over all the files which got sent and check at first if it is application/PDF type. If not, we will send back invalid file type, else we are going to call file.read and append the contents to the PDF bytes list and close the file again. And finally then we're going to call add documents from PDF bytes from the PDF bytes list we just created and return a JSON response 200 documents added successfully. I'm just going to add another function to our utils file to create the API key. So we're going to import secrets and going to create the function define generate API key with the call secret.token hex on and create a token length, and the token length as default will be 32. So with that you can create your API key. Okay, I just create my API key. Now let us test out if everything works. Create a virtual environment and install our requirements. But first upgrade pip, and then pip install -r requirements.txt. Now that our requirements are installed, we just need one more addition. At the end of the FastAPI app, we write if name equals main, unicorn run app, which is our FastAPI app, and hosts is just 0.0.0, which is our local host on port 8000, and then we can just run it, FastAPI app. Now we can go on 0.0.0:8000/docs, and here we have our automatically created documentation. We can see to get our matrix, we have to provide an API key, and the response will be in JSON then. To upload the file, there's an array or list of files required, and now we can easily test it out. So I'm just going to create sample code to upload a document. Okay, here's our test upload.py file. We're just going to get the FastAPI key from the .env file where we have saved it, then read all the files. In this case I'm just going to upload one PDF file as bytes at application PDF and post it to the URL, which will be 0.0.0:8000/upload. And now we can just test it out. Split terminal. Let's call python3 test upload.py. Now we can see it's loading the embedder model, and there's a small error in the add documents file. I called it embedding function, but it's called embeddings. Okay, let's just run the app again and send the document again, and we can see now the database has been created and we have received our response message that the documents added successfully. And with that we have our endpoint created. The last thing I want to do now is create two Docker files, one for the Telegram bot and one for the FastAPI endpoint, and then create a Docker compose file so that on the server we just run Docker compose up as the -- build, and with that everything gets created automatically. Okay, we're going to create a Docker file.fastapi and a Docker file.telegram. So if you don't know what Docker is a containerization software. You can imagine it as a smaller, lightweight virtual machine. We can create an image, and this image has as the base, say, Ubuntu from Linux. Then we're going to install our requirements and write the command. If the container from that Docker image is being run, then our FastAPI app is going to be called and will be running. And we can then copy and we can share these images, or share the Docker file in this repository, and someone else can create the image and can then easily install the code here without the necessity to think about the installation of the requirements and everything. There might be some more complex steps involved sometimes. There might be, if time goes on, then different versions of different requirements exist. And with Docker we can basically save the state as it is, containerize it, and then you can easily deploy it without headache, so to speak. Okay, and here's how our Docker file Telegram will look like. From Python 3.9 Slim, this will be our container base. We are going to create the work direction app. We will copy the requirements inside the container. We will install the requirements, and we are also going to create an entry point, which is going to call entrypoint.sh, and this entrypoint.sh, it will simply just call the SQL operations.py file. which will create our database if it's not existent. So with that we ensure that when we are deploying our code, our SQL database will directly be created for the tracking of our token usage and cost. And then we're going to run telegram bot.py, which will keep our Telegram chatbot running. And now to our next container, our FastAPI container. The beginning is the same. Here the base of our container, create the work directory app, copy the requirements, install them. We're also going to install Unicorn, and then we're going to expose the port 8000. So what this does is from our container, we can then communicate from outside to the port 8000, and our FastAPI app is going to run on the port 8000. Therefore we need to open it up to communicate to this port and to our FastAPI app. So then we're going to be running Unicorn, or also called Green Unicorn. This is a Python web server gateway interface. It's basically sitting between our API endpoints and user who sends requests to our API endpoints. It basically abstracts away some complexities for us and makes it easy to set up our server here. So this is the command we're going to use. Unicorn, the number of workers, we just need one worker now. I'm going to set the timeout to 120 seconds since the adding of documents could take a little while, and yeah, we have to map our FastAPI Python file name to app, and then we're going to bind it on the local host with the port 8000, which we just exposed. Then with that, we just need to create our Docker Compose file, and then we're ready to deploy it. So we're going to create a docker-compose.yml. And this is how it's going to look at the end. We have our services from our document chat, the FastAPI app. So these are the containers, basically. Our FastAPI app container, our Telegram bot container. We are going to expose the ports 8000 for our FastAPI app. And yeah, we also want to bind the current directory into the Docker container. So we don't have to copy the whole content of this directory into the container and use the Python files. Both services or containers can work with the same databases, and also if files are created, they're going to be saved in the directory. And with that, we can make a quick test. Open the terminal again and run docker compose up --build, and let's see if everything works out. This is going to take a little while because the container have to be built and all the commands need to run, so the pip install for example, and therefore we need to wait a little bit, a couple of minutes. Okay, it's built, the services are running, both containers are running. Now we can again check out the docs endpoint of the FastAPI server and see if everything works, and there we have it. It is running inside our containers, and with that we can easily deploy it. Also, as you can see here, the Telegram bot is also running. Everything works. Okay, let's stop this, and I'm going to upload this on my GitHub, and then we're going to deploy it on a server. So let's see you in a second. Okay, I just created the GitHub repository, document Telegram chat deployment. You can head over to DigitalOcean. I have a link in the description. You get $200 for 60 days, and with that you can play around with deployments and test everything yourself. So I have an account, I'm going to log in. Here left you can create new projects. I just have the default first project. So here different possibilities to deploy your apps, directly deploy web apps, or using functions, Kubernetes. So we are going to spin up a droplet, which is basically a virtual environment. We are going to take an image which, from the marketplace, one which has Docker installed on it. So just select that. Then yeah, well, you can choose a dedicated CPU, which then will be of course a little bit more expensive per month. I'm just going to take a shared GPU since yeah, we're not going to use it 24/7 and necessarily need it. Just going to get a regular SSD disk type, and I'm going to take one CPU, 2 GB, 50 GB SSD. This should be sufficient for this simple application, and with that you can also enable automated backups. I'm just going to connect via SSH. I already have my SSH key created, and with the SSH key we can log in from our computer to this virtual machine. And yeah, you can just create a new SSH key and follow the steps mentioned here, and then copy the contents into the field you see there. Okay, we can add improved matrix monitoring. We just need one droplet, and with that click on create droplet. Okay, it's created. We can click on it. Here we have our IPv4 address. Now we can copy our IPv4 address and SSH into it. You can also just launch the droplet console directly, but I like to do it in this manner. SSH root give the IP address. Then I'm going to write yes, and we're in it. Okay, I'm going to copy the repository here. Clear. Now git clone the repository into it, cd into our repository, and there we have everything. We want to nano in the .env file and then write our keys inside there. And after you insert your keys, we can simply again run docker compose up -- build, and in a little bit when it's created you can access it over the internet. Okay, everything is up and running. Now we can test it out. Let's take our code again, and we first need the IP, and then we can upload our documents to this ID. I'm just going to upload a GPTQ PDF file, which is about the GPTQ quantization method. So let's just call Python test upload, and we should see something happening in the terminal, and there we see our embedding model gets loaded, and documents are going to be saved inside the database, and documents added successfully. Now let's check it out by chatting with it in Telegram. Okay, now in Telegram in the specific chat, now I'm just going to ask tell me about GPTQ. And let's see if our Telegram chat is also working properly. And there we get our result. Wonderful answer. Okay, now the last thing you can do is check the matrix endpoint, how much this has cost us. So I just created a getMatrix.py file where we're going to call the matrix endpoint and print out the results. So -3 getMatrix.py, and there we see we have for our last request we used in total 3,292 tokens, which cost us 0.5 cents. So we can also hop over here to graphs and see what is happening in our deployed server, the CPU usage, the input output on the disk, bandwidth usage. We can see everything here. And with that, we finished with this video. I hope you could learn something. I hope you could clear up some misconceptions, understand the deployment process a little bit more, understand the hardware requirements behind it and the costs associated with all of that, and why it in many cases is just better to use the OpenAI API. So leave a comment if you have any more questions or want me to cover other topics. Click the like button, click the subscribe button, and see you in the next video.